Today we are going to talk about using the generative AI models and large language models in more specifically speaking to create a sort of interactive chatbot for us so it can respond to some domain specific questions. And for this presentation, I um, aim to use the information about like finance and banking. So we use the very popular bank in Australia, Commonwealth Bank, or in short, a CBA. So without further ado, let's go and see how it works. Some features, if I'm gonna explain, is it should respond to some domain specific, so to the home loans, saving account, and credit cards, for example, kind of questions. And I would like to make it like more interactive, so it can record and talk. It is cost-free. The models and data both are cost-free. And we know that the banking systems and insurances, all financials are quite um, very sensitive about the privacy of their customers. So no data will leave the machine. So the model is downloaded locally, so no data leaves the machine. The model is computationally not costly and low weight, so you can, and it will be run on the CPU. I appreciate that it's not as interactive, but I think this is what we would for this sake of the presentation. And then um, given like it can be scalable for the later use. It doesn't rely on the paid API services such as ChatGPT, so no cost, no customer data will be compromised. So overall speaking, this is how I encoded all the data to the format that the machine would understand. I gather as much information publicly available on the Commonwealth Bank of Australia. Obviously, we need to pre-process them and then put them in a vectorized format that the machine does understand only the vectors and tenses and numbers, not the words or tokens. And then we use this tool to put it in a vector database and make some understanding out of it. Going down to the details of the coding and programming part, I tried to automate the entire pipeline. So that's the reason why I used the request and the rest of this libraries. Obviously, the language is Python, and try to make some smart queries, but it's not the prompt engineering. And as you can see, like these are the very basic queries I used to search for data, and I gathered around 37 text files, which is not much in terms of size. And then obviously there is a data cleaning. So the super easy way is the RE library. I removed the white spaces, any repeated phrases, and header footers as well. And then it is the chunking time. So we chunked and split all these into smaller pieces, each 2 kilobytes. So having like 2,000 characters, which is around 300 to 400 words per chunk, we got like 148 chunks. So this is to have a perspective what's going on. We get the text, and after like all of those pre-processing things, we just feed it to the machine. So it is all the words are mapped to a vector space where similar meanings are close together. it learns like which words are more informative in the context. For example, fixed rate loan against the preposition there, like the THE. And this is a fully connected layer. And then we come all the way to the multi-head attention block. This is the core of our job. It's the core of the transformer. So yeah, in here, it is the heart of the transformer encoder, and it lets each word look at other words in the sentence and decide which are the most important in each sentence and the entire text. Say our query is, can I use my credit card to pay off my car loan? And then it tries to relate them all and have some semantic information. So I hope it makes sense. So it helps, the model understand text, such as in the sentence like this, how they can be connected and linked and find which one is more corresponds and relates to the other in more strong manner. So in general, the multi-head attention block, thanks to the attention, is all you need by the Google team back in published in 2017. In overall, it improves the quality of embeddings by learning dependencies. So all these should happen, and you will, at the end, ultimately, you will see only the front end. But I need to explain under the hood of what's going on. Say here, we need to embed the chunks using this sentence transformer. It maps all these into a dense vector format, the format that the machine understands. So everything will be vectorized. I mean, so many dimensions, and it will be stored in memory over a RAM. I may publish another, record another video in further details. What are these models? So, for example, for here we have the mini language model version 2 of the sentence transformer. And then we have the Chroma database to store all of this information in memory. So it will help to find the K is a number, say 3 top relevant chunks, and then helps with the retrieval. So again, the overall scheme and layout is like we have another input as the user query. We again embed it and use the Chroma database to retrieve it, make it more readable, find the information relevant, and the magic happens all over here. And hope I can record another video to explain under the hood of the language model and why we call them large language models. And final, the last steps in the last two or three steps in the decoding. We need the retrieval. We load the quantized model called Mistral with the 7 billions of parameters. As you see, we have like three. We just look at the three relevant chunks out of those. If you remember, 148 chunks on my machine, and retrieve only three of the chunks. And then it will be summarized into only 4 to 5 sentences. We will see an example shortly, and use my locally downloaded large language model. One package that will be help to generate the response is the GPT for all. So it generates the response out of the prompt. So we, as you recall, we did the encoder, and now we built also the decoder, very similar to attention, all you need. But of course, we did some tweaks, not similar way. I try to simplify that, but we use the transformers anyway. And then there was a little bit of a part that I need to do the manual. I couldn't make it automated, so I downloaded this file thanks to the Hugging Face. And to know more about the details, like it has 7 billion parameters. It is quantized, and after quantization, it is only 4 gigabytes, and it's still kind of like big. So what do you mean by quantized? I'm not gonna go into the details, given even for myself, it is kind of novel and new concept and context. So this is a very detailed domain, and we just know like we try to reduce the size. So the memory usage and the size will be reduced by storing parameters with lower numerical precision, enabling fast, efficient local inference with minimal quality loss. Say here we have, if we have 7 billion parameters, like this model, so and each parameter will correspond, you need to represent it by on the memory. So we need, say, 2 bytes, sorry, at least. So we need around like 14. They are all truncated and rounded. So for the sake of the argument and simplicity of the presentation for today, so if we have, say, 14 we will have 14 gigabytes of memory only for the presentation. Then we need to update them and optimize them. So each need another 2 bytes. And then on top of that, okay, if we are gonna fine tune it, we need another uh, another four times four bytes for each. Say if you're gonna choose the Atom optimizer, which is widely used. So I think this way I'm trying to get you to get a sense of what we are doing. So if we are gonna like do a perfect job, we are not gonna like storing, we are gonna retrain them. And the bulk of the memory footprint, if you are going to use the 32 format, for example, footprint, uh, together they will all occupy 98, close to 100 gigabytes. And these are not about, not talking about the memory and storage. They are going to be all used for the GPU and processing, either on your CPU or GPU. And that's kind of massive, and that's the reason why we call them large language models, given time, this large number of the massive number of the parameters on them. And we have like, so the final answer will be 4 to 5 sentences. We try to have a friendly answer and use the local a GPT for all model, as I said already. So this is how this ultimately model would look like. I'm running a Python file for this, and then it shows up on your browser. The good thing and sweet thing about this matter is you can ask your question by recording. So, and the ultimate goal is to make it available for conversation finally. But this is the very baby step that we just took here. Say if I ask this question, I'm gonna like put the question is, if I clear my other debts using my Commonwealth Bank credit card, will it make my repayments easier or could it backfire? This is the question that I asked, and it recorded my audio. And you see, like it's all has all the aspects of being financial. It should need caution, and there is a risk of hallucinating. So it it doesn't hallucinate. I think I forgot to talk about this aspect in my presentation. So what we used is trying to prevent any sort of hallucination, and it shouldn't. It prevents any sort of the hallucination. So the model serves as a local instruction tuned and is responsible for generating final user-facing answers based strictly on the retrieved Commonwealth Bank document context, ensuring private source ground and concise response without reliance on external cloud services, which means that it is not based on its own internal training or memory. So let's get back to our question. This is like how it answers. Based on the information provided, it's not possible, blah, blah, blah. So it doesn't give you the exact answer, but it understand the concepts and answers. So I try to challenge it. This thing I think took like 3 minutes on a typical laptop. I tried on a couple of machines. But I try to challenge it with more challenging question, which is if I clear my debts using my Commonwealth credit card, will it make my repayments easier? And then this is the answer. It says clearing your other debts using your Commonwealth Bank card may not necessarily make your repayments easier. And it goes all the way, it gives like these 1, 2, 3, 4 chunks sentences of for the answer, and I think it has an understanding, and also it is cautious. It doesn't hallucinate, and it also mentions the interest rate, and this zero balance transfer means that it doesn't hallucinate or makes like some sort of unrealistic estimation or so. So this is the very baby step, as I said, and we need to move towards more optimized, fast framework. So having like more data available and better and more computationally capable and more capacitated platform, we can use more GPU memory and processing as well, but not for the current step. We will try to use the fine tuning, so they all come together. Of course, it is more computationally expensive, and then the latency will be reduced and expand to broader financial data sets, 37, and with those prompts not needed, so we need to engineer more of the prompts. A better model, yeah. I think you all know about the OpenAI. So this model would help us to get the answer that we are after more specifically in details. So with this OpenAI, for example, can ingest the question and queries more in detail, um, along with the better prompt engineering. And the feature that I couldn't add in Chroma database was the persistence. It helps to further for better retrieval. And then finally, we are going to add the geospatial, some satellite recognition, object recognition to this job. Thank you very much for watching this.